All right, so once those bytes start delivering to the browser, we can move on to our paint metrics. And the first one we'll talk about is first paint. Now, to recap from the metrics section, when you first make a request to fetch a website, after the first byte timing stuff that we discussed finishes up, the server will start to respond with some HTML for the page that you're looking for. And that HTML streams to the browser. The browser can render parts of the page as it streams, even before it's fully loaded. And that's something that other technologies on the web don't really do quite as well. HTML is really special like that. But to even start rendering any of that HTML visibly, as I'd said earlier, it needs to be free to do that, because it will stop rendering if it encounters a reference to an external file that it needs to request before it can proceed. And that's because when the browser receives the HTML, again, it scans for these references to files that it needs to go fetch before it can start to proceed with rendering. And in the case of references to files like CSS and JavaScript, the browser will just stop rendering the content while it loads and evaluates each of those files. And each of those requests, of course, involves fully traveling to the server and back. And even at the speed of light, we know that that time adds up. Hopefully, at least, those files are on the same server that the page was on. If not, there will be additional delays in connection timing as well. I said before that from a user perspective, when the browser already has the HTML and it can't start rendering it, it's effectively broken, even if temporarily, but potentially not temporarily too, which is why we call these a single point of failure. I was actually curious, so I tested how long various browsers will wait for a script to load. And 20 seconds or more is pretty typical. iOS Safari even waits as long as 75 seconds. Of course, that's a worst case scenario, but when things are working as expected, these delays are still common. This delay of blocking file latency is experienced by all of us every day. The HTTP archive reports that the average time to first contentful paint is 3 to 4 seconds for mobile browsing. They don't report averages for the first paint metric, which is the one we're talking about now. And that would, of course, happen a little sooner in most pages. But this metric is good enough to know what we're talking about. This particular delay happens, and we want to start painting sooner than this. So let's look at the code that causes these delays and how we can fix it. So the HTML, again, behind these requests, as I noted earlier in the metrics section, tends to look something like this. Link elements and script elements. These are the render blockers. The heavy images, the videos in your page, those are not the ones that are holding back the page from rendering, right? It's these. And these are standard markup. But from a performance perspective, they can start to be an anti-pattern. We want to eliminate or mitigate the default behavior of these elements before our content. Fortunately, we can do better than allowing these to be single external points of failure, preventing us from displaying the HTML as soon as the browser receives it. So we need to get them out of the rendering path still. The first thing to consider is whether any of these assets really need to load and run at such a high priority at all. If they aren't critical to render, then we can decide to load them in a way that doesn't block rendering at all. For JavaScript, that's a lot more of a common pattern. We often can let JavaScript load on its own and apply whenever it arrives, allowing the page to show before the JavaScript is even there. And to do that with scripts, it's as simple as adding these attributes, defer or async. Either of these will allow the content that comes after them to start rendering. Now, what's the difference in those between async and defer? Well, async, I think, is less commonly useful. Yes, it allows the page to render while the script loads, but it executes whenever the script arrives, and in any order that it arrives. So this is okay if you have a script that's truly independent of anything else in your page, and you just want to start it running as soon as possible. But defer, I think, is a little more useful. Defer lets the page render while scripts load as well, but it also respects dependencies and order of the scripts that were requested. So it'll go by the order that they're listed in the page. They'll request in parallel, but they'll still obey the order that they were referenced in when it comes to when they actually run. And deferring JavaScript is one of the absolute most important things you can do to speed up rendering and time to first paint. I have this example from the Telegraph website. They deferred all their JavaScript and saw their render time, even on fast connections, drop by 4 seconds. So you can see the two timelines there. And that was just a result of deferring their JavaScript. There are a couple other ways that we can defer JavaScript too. A script with a type of module is one way. Modules are ways to load a function that other scripts can use, and these are deferred by default. So if you happen to write your scripts in a way that they're exporting a module, then this is something to consider. Another way is to generate a script using JavaScript and inject it into the page dynamically. And this does the same thing as running a defer script, because I have set the async attribute to false, which basically means defer instead of async. So it'll load in parallel, but it'll still evaluate and execute in the order that it was called in the page. And what's neat about using a script to generate your script tag is that you can decide whether to fetch a file in the first place. And a script tag alone with a defer attribute doesn't give us that power to conditionally request or not. So maybe we could avoid loading JavaScript files at all if they aren't needed for a particular browser. Tools like Google's Analytics use patterns like this to actually generate the script and inject it into the page. And it lets them generate the loading code dynamically to add certain conditions about the browser before it's requested. Lastly, another way to get JavaScript out of the way is to just move your script tags to the end of the page. This is great because it naturally deprioritizes the request, so more important stuff can go first. But it can end up making scripts load later than you want as well. So if they're at the top of the page, look for ways to defer or make them async. Otherwise, you could move them to the bottom and get a similar effect like this. So what if you wanted to make your CSS load without blocking render? Well, that's doable, though it's not as intuitive as with JavaScript. And that's because there's no way to add an async or a defer attribute for CSS like there is for JavaScript. So by default, style sheet links will block rendering, and there's just no simple standard opt-out for that. But there are attributes that happen to trigger non-render blocking CSS loading behavior. One of those is the effect that we get when we make a print style sheet, which is any style sheet link that we add media equals print instead of something like screen or all. If it's a print style sheet, naturally it will download in the background and let the page render while it's downloading. And for print specific use cases, that's great because the style sheet is not necessary for rendering the page on the screen. It's only there for when the user decides to print the page. So that will actually trigger asynchronous behavior. And that's sort of interesting. We can take advantage of that behavior. And it can be sort of a primitive for the loading behavior that we want. So we could start by setting the media attribute of our style sheet to print, and when it loads, set it back to something that makes it apply to the page, like all or screen. So that's essentially the same behavior as an asynchronous JavaScript file. That said, it's actually rare that we want this behavior in CSS at all. And that's because with CSS, if we show the page before it's ready, it will be ugly and unstyled. So you'd see something like this first. And once the CSS loads, suddenly you'd see something like this, right? And that's called a flash of unstyled content. And we don't want that. It's terrible for usability. So this is a good case where we could show the page content potentially sooner, but it's not actually helpful to do that. So some part of our CSS does need to block rendering. And that's true of JavaScript sometimes too. Some JavaScript really should run up front before the page is allowed to render, as long as it's very light. Having a little JavaScript running right away can help us deliver a first rendering of the page that's more appropriate for a variety of device conditions. Things like testing features that add a class to the HTML element to help us enable certain CSS layout features if they are supported. That kind of stuff is useful to do early and very quickly before the page is shown for the first time. So you could consider that kind of JavaScript to be critical in a sense. And the rest of it generally isn't. And it's not just about features. It's also about setting up the first rendering of your page to match the eventual state that it will look like when all of the JavaScript applies to the page and enhances it. Sometimes we serve basic HTML and then we have JavaScript that enhances the interface with slightly different behavior that wasn't there in the first place. And what we want to do is deliver a page with one smooth rendering that gets to that end state as quickly as possible. But it's hard to do that if the JavaScript that drives that end state is loading in a way that lets the page render before it's even there. One pattern that I find helpful when I'm trying to show the meaningful version of a page much sooner is a pattern that I like to call enhancing optimistically, which is that there's just a small amount of JavaScript in the head of the page that adds a class to the HTML element that says the page is being enhanced. So you could add a class of enhanced, for example. And that class will be used by the CSS to apply the final layout that will eventually be useful when the JavaScript finishes loading. So you can see that in code here. We're avoiding a flash of unstyled content by adding a class early. You can see it at the top here. We're adding a class of enhanced, and then we can style based on the presence of that class in a way that reflects how our eventual layout will look when the JavaScript applies to it. Now, since we're doing this, we have to be cautious because there is a chance that the JavaScript that we're loading may fail to load at all, right? So the thing I like about this pattern is that we apply the class early and style the page as if it's enhanced, and then we make the request to our script. But we also give ourselves a fallback that if the script doesn't load in a reasonable amount of time, we can remove that class again and sort of degrade the UI back to a state where it was initially delivered before the JavaScript arrived. So you kind of give yourself that out to hopefully provide a usable experience even if something goes wrong. So we've talked about the critical code that we need in the top of the page that should block render. But our challenge with these important render blocking files is that we want them to be ready to run right when we need to use them. And that means we have to deliver them faster alongside our HTML. So I like to think about page delivery sort of like when I'm leaving the house and I know I'm not going to come back for a while. So I want to make sure I have everything with me that I'll need. And there are a few things that we can do when we deliver our pages to make sure that we bring everything that we really need along with us right away. So another approach we have is to inline our code instead. And in many cases, this still may be your most reasonable approach for getting your critical code to the browser today. Google's documentation says if your external CSS is small, just inline it right into the HTML. And they've been doing this at Google Search, for example, for decades. And it just works well. Avoid going to the server, and you just have it right there in your HTML. It's very fast. So inline does require changes to your HTML itself, and that's a downside. That is, embedding code inside script or style elements instead of referencing them externally, like we normally would. So here's an example where the contents of a CSS file are dropped right into a style element in the page instead of referencing that style sheet with a link. Now, looking at this quickly should highlight for you a big drawback of inlining. It's really bad for caching. That CSS is meshed into an unrelated file and not able to be referenced on other pages of the site. So with the CSS inline, it's essentially gone as its own individual file. It's like trying to get the jelly out of the peanut butter and jelly sandwich after you made it. So to get that CSS file, you might have to load it again later individually in a non-blocking way just to get it into cache so then you could reuse it as its own file. And that's unfortunate, but the benefit in performance is often worth it. And I'll get to some mitigating strategies that pair well with this in a later section. But again, you also don't want to inline anything that's too large. If the CSS is too big, you won't want to inline the whole thing up front because you'll put too much unimportant code in your first response. And where to draw that line of what is too big is kind of tricky. Generally, I find that if your CSS is more than 15 to 20 kilobytes, it's big enough to start thinking about breaking it apart by priority or by different means, like different templates or how much of it is used in this particular view that you're trying to load. So here's the tip from Google's PageSpeed Insights. And it says, identify and inline the CSS necessary for rendering above the fold content. So in other words, they're saying we want to extract the CSS rules from our style sheet that are necessary to render the first screenful of the page. We tend to call these rules critical CSS. And this technique has been around for quite a while, but I can't help but mention it because it can make a huge impact on particular sites that have really heavy CSS across all their pages. Here's a visual comparison to describe what we're talking about here. So on the left is a homepage template from the Vineyard Vines website, and on the right is that page with only its critical CSS loaded. And it looks identical. Now, as I start to scroll the pages a little, that's where our layout sort of falls apart into a linear layout on the right, while the left has its full intact layout. This is the effect of loading a page with only its critical CSS rules. It tells us that we've extracted the important stuff that's only needed to render the top of the page. In code, that might look something like this. So you have your full CSS in the left column here, and then a subset of that CSS for styling the top portion of the page across all of your breakpoints. So the critical CSS is, again, a subset of your full CSS. So how do we know which CSS is critical for rendering the top portion of the page? Well, easy. Just open up your CSS and copy the first 100 lines or so, and that should do it. Obviously, I'm kidding. We have tools that analyze a page's CSS and extract the portion that are used to render the critical portion of the page. One of those tools is called Critical CSS, which is a command line utility. Another is Adi Osmani's Critical project. And either of those will open a given page of your site in a browser behind the scenes and abstract out the CSS necessary to render just the top of the page. And it puts that in a file, and you can inline it like this. So that gets the initial blocking CSS into the head with no return trips needed. But again, that's only a subset of your CSS. You just broke it all apart, and now you're only loading a part of the overall CSS that you need. You want to load the rest too somehow. So this is where we can go back to that non-blocking asynchronous CSS pattern that we talked about with the print media. So we can go back and add this to the page and load the full style sheet that way. So we load just the critical styles up front in an inline or a pushed scenario, and then the full site CSS can come in a deferred sort of loading pattern. So this is a pretty good pattern if your CSS is in one big chunk and it's just too big to inline the whole thing. But also you can think about different ways to break it apart, different than just critical and non-critical styles. For example, you could break your files up into contextual packages for each template. So a good way to think about that is shared CSS rules versus template CSS rules. And you can think about the same things for JavaScript. Global JavaScript functions versus functions that are relevant to just a particular component or page. So this is another way that you can cut down the overall weight of the code that you're delivering to a page. And splitting up files this way is great also because it could mean that a subsequent page on the site could reuse some of the files, but not all. So you're starting to come up with a caching strategy that works across all pages by smartly sharing some files while delivering some files that are only needed on certain pages and not others. Another way to think about loading your CSS in a more performant way is to use media queries to load CSS for different viewport sizes separately. And what's neat about this is a media query, when it doesn't match, the file will still load, but it loads just like a print style sheet does. It'll load without blocking rendering. So if you're looking at this particular CSS stack, if you will, and you've got global CSS followed by global small for small screen and then global large for large screen, a small screen device would load the first two style sheets in a way that blocks render while not blocking render to load the large style sheet because it doesn't need it for its particular viewport size. So that's another good strategy for lessening the load that you deliver. So to recap, initial paint is all about placing the most important parts of your code in the way of render and getting the rest out of the way of render. And for the stuff that's in the way of render, we want to make sure that we're delivering it alongside our HTML as tightly as possible. So we do that by inlining or referencing as little as we can in clever ways. And then we want to defer the rest. So that's pretty much it when we're talking about starting to get pixels onto the screen.